is going to be similar to what we've done already. Because if you notice, most of the stuff we covered yesterday was just taking what we've already covered and just taking it a step further. Same with this here. Because we've already talked about inequalities and solving exponentials with inequalities and logarithmics and inequalities. And I just wanted to look at some that had a little bit more to them than what we covered. Because most of the ones we covered were very basic. It required 1 or 2 steps, and we pretty much had solved the thing. Here is going to require a few more steps. And
is that x to the power?
yes. Now, the note sheets do need to be adjusted slightly because we need it to be 303. I was looking through the note sheets and going through them a little bit this morning and noticed if the number was 13, it's actually a little too small. It actually doesn't give us any solutions for this here. But the overall process of what we're doing is not going to change too much. And we will not get a quadratic from this here. Well, we'll have x squared, but we're not going to have something that we have to factor or use the quadratic method or quadratic formula to solve. We can do this by our square root method, is essentially what we're going to use. Now, when we look at this here, e to the x squared plus 4 is what we want to get by itself. Well, the first thing we can do to get it by itself is to subtract the 3 from both sides, which would leave us 5e squared 4 is less than 300. And then we would divide by 5. And now tell me e to the x squared plus 4 is less than 60. And I picked 303 for a reason, because once we get e by itself, it'll equal a whole number. We're not dealing with fractions. Yes. Because to get rid of e, we're going to need to apply the natural log to both sides. Because this is 1, and we can move the x squared plus 4 out front, and is less than ln of 60. Mm-hmm. We subtract the 4 from both sides, which tells us x squared is less than ln of 60 minus 4, yes. We're going to need to square root both sides, because our square root method was we get the x squared by itself, everything on the other side. Because the only way we can use the square root method is if we have a set of parentheses squared or variable squared by itself. We don't have any middle terms. And we would square root both sides. Yes. That's fine. Well, when we look at this here, because we know that we need to take the square root of both sides because the square root and the x squared simplify. Now, whenever we take the square root of both sides, we always have to add what? The plus or minus. The plus and minus, because when we take the square root of both sides, we have the plus or minus. But what's interesting is with inequalities, we actually end up getting 2 statements. Because remember, if we multiply or divide by a negative, we have to change the sign. The same thing is true when we take the square root of both sides. Because when we have this plus or minus case, it ends up splitting it, where the positive case, the symbol or our inequality sign stays the same. Our negative case, it flips that inequality. It flips the inequality sign. And this here really would be our answer. We could round it. We can plug those in and round to the nearest decimal place. But it's not going to make that big of a difference because it's just going to give us the same number as this here. And the reason this is also one of the reasons I had to change the answer, because if it was 13, it actually comes down to the natural log of 2. So the natural log of 2 is actually smaller than 4. So we get a negative number inside of a square root, which does not have an actual solution because it would be imaginary. So I did change it and get this here. Now we don't have any cases where we have to make sure x is greater than 0 because it's in the exponent, not inside of a log. Any questions on this here? And that's it. That's all we have to do for these here. We'll look at one more case with exponents dealing kind of mainly with e, and then we'll look at one or two dealing with log, and there's a tidbit I'm going to have to add back in. I would minus 5. Because we're wanting to get e by itself. Mm-hmm. You're good? Yeah, so we would minus 5 from both sides. And our 14 minus 5 would give us 9. Then we can multiply both sides by negative 1. Dividing by negative 1 will do the same thing. And this will tell us that x is less than negative ln of 9. And that's it. I mean, at this point here, we can actually go on and plug ln of 9, or negative ln of 9 into the calculator. Mm-hmm. And that's all we'd have to do. Any questions on any of this here? Now, the way that we've written this here and the way that we would think about this is a little bit different, because if we wanted to be mathematically rigorous, we would really need another set of parentheses around the 2x minus 3 cubed. Because if we treated it as the natural log of 2x minus 3 cubed, we're really cubing the natural log. We're not cubing what's inside. But because of a lot of what we're doing, we really want the cube to be attached mainly just to the 2x minus 3, not to the natural log of it. And really what it's saying is that it looks like this. So you don't write that because that's not actually what we're going to have. But what we're going to do is we're going to treat it like it is this, to where that 2x minus 3 is being cubed. Because it will change the answer and how it looks. Because if it was attached to the natural log, we'd have to cube root both sides to get the natural log by itself. But since this is attached to the 2x minus 3, our power root says I can move the 3 out front. We would get rid of it, but not minus or plus, we would divide. Since these are being multiplied, we would divide. Now what would we do next? We would add e as a base, and I find the wording of it kind of hard to say, but we're putting both sides to the base of e, because our e to the ln does simplify, leaving us with 2x minus 3. And lastly, by 2. And this is it. Now, since we are talking about logarithms and natural logarithms, we do have those restrictions because what's inside the logarithm cannot be 0 or negative, actually. Because when I was looking back at this, I realized it actually can't be 0. And I was saying that wrong when we were working it this week and a little bit of last week, or actually it was just this week. It can't be 0. So what's inside of it has to be greater than 0. And that's the only real slight change, because what is really changing is when we checked for our restrictions of what it had to be greater than, is that we would use greater than instead of greater than or equals. We just drop the equal sign off. That's the only real change. Does that kind of make sense? Now, it's actually not that bad. To show, because log base b of 0 equals x. Well, I can apply, if I were to solve this, base b to both sides. Well, those would cancel, telling me b to the x is equal to 0. Well, one of the first things we covered with these exponential functions, exponential growth and exponential decay, is that there is not an exponential, no matter what the base is, that will ever equal 0. This would never work. So we can't have 0 inside the log. Let's see here. We're going to do one more. So out of the 3 that are left, because I'm not going to bore you with all these, which one do you think would be the most interesting? The last one? Yes. Now, this here is especially the reason I was talking about the parentheses. We're going to treat this -1 as being to the x minus 6. So if we're really looking at it and being particular, it would actually have to be written this way with an extra set. Because without that extra set of parentheses, really what we're looking at is this here. Because we'd be moving it down, which would change our answers completely. So really what we're looking at is -2 ln of x minus 6 to the -1 is less than or equal to 6. This is really what we're looking at. Because if we have it the other way, it actually makes the answers really funky. Because we end up getting a section, a gap, and then a section of the actual answers. We'd have 2 inequalities. So when we look at it this way, we need to get the natural log by itself. And the first thing we can do is divide both sides by -2. Which will tell us that we have the ln of x minus 6 to the -1 is greater than or equal to -3. And I do notice that I did drop that extra set of parentheses. But we understand that that -1 is not attached to the natural log. It's attached to the x minus 6. I'd throw that -1 out front. Now, it's not that there's anything wrong with doing e, because we can do e at this point, and I'll show you that here in a minute. But it's going to work a little bit nicer if we have negative ln of x minus 6 is greater than or equal to -3. You don't have, that's an ln. It's just you can do ln like we've been writing it. If I don't watch it, I fall back into my old habits of writing it that way. And then I want to get rid of that negative. Here? Yeah. Okay. Whenever we multiply or divide by a negative, we have to change the sign. Because this, whatever it is, was going to be negative because of the negative 2, yes? And it's less than a positive. Well, when I divide it by negative 2, the natural log is now, and what the 6 is now negative. So the signs on both change, yes? So that inequality needs to flip with it. Now, I moved the negative 1 out front. Yep. And I want to get rid of this negative because if I can get rid of negatives anywhere near the x, I try to. Because the negative and negative would be positive L in x minus 6. Well, I multiplied by negative, so I have to flip it back. Now we can take it by e. And these here would cancel, leaving us with x minus 6 is less than or equal to e cubed. X is less than or equal to e cubed plus 6. Well, we have less than, don't we? So that means it could include negatives, and we can't have negatives inside of the natural log. So what was inside the natural log was x minus 6. Now this has to be greater than 0. So what we can do both sides is add. So x is greater than. So this here would be our entire answer. 6 is less than x is less than or equal to e to the third plus 6. Now, if we were wanting a very exact answer, I would leave it as this here. Because we know e is a non-repeating, non-terminating decimal, so we can't be precise if I turn it into a decimal. Now, here. I'm going to erase all of this here. So, I want to go back here and show you this part. Because it's not wrong to actually apply e here. Because these here will still simplify, and what I'm left with is x minus 6 to the negative 1 is greater than or equal to e to the negative third. Well, at this point, I can't move the negative 1 out front. Because the only reason we can move it out front is because of the properties of logarithms. Lets us do that move. But I do know if I want to make an exponent positive that's negative, I move it from the numerator to the denominator. So over here we'd have 1 over x minus 6 is greater than or equal to, well, this here would be 1 over e to the third. Now at this point here we can use something called cross multiplication. I don't like using that terminology, because really what we're going to do is just multiply both sides by the denominators. Okay. Oh, I left it down there. So here, these would cancel, and these would cancel, leaving me with e to the third is greater than or equal to x minus 6. Well, add 6 to both sides, and we get e to the third plus 6 is greater than or equal to x. Now that looks like we got a different answer, but if I flip x, I put x on the well, that's exactly what we got from at the beginning, or when we did it with moving the negative 1. But moving this here is a little bit more tricky than if we just moved the negative 1 out front, yes? So if we can get rid of powers and stuff like that first, I try to get rid of it because it makes it a little bit easier to work with. The only other thing we'd have is that adding this in from finding out what's going to make x 0. And that'd be it. Questions on this here? If not there,